Today we are going to discuss the laws of thermodynamics. I remind you that we are continuing the uh, subject, that is chemical thermodynamics. Under this, the subtopic laws of thermodynamics. It may come to your mind that what is thermodynamics means. Thermodynamics is derived from two words, that is thermo plus dynamics. Thermo means it is heat, thermos, heat, and dynamics means motion. That means it is relating to the laws relating to the uh, heat flow. Regarding on what, that is on system and surrounding. So regarding this, first comes Zeroth Law of Thermodynamics. And in the Zeroth Law of Thermodynamics, we can state this law as given here, that is, if two systems A and B are separately in thermal equilibrium with the third system C, A and B, A is in equilibrium, in thermal equilibrium with C, and system B is also in thermal equilibrium with C, then it is evident that A and B must in thermal equilibrium with each other. So A and B must be in thermal equilibrium with each other. So this is the very statement of zeroth law of thermodynamics. Then we will come to the first law of thermodynamics. The first law of thermodynamics is the conclusion of law of conservation of energy. So the basis is the law of conservation of energy. What it states? It states that the energy can neither be created nor destroyed, but it can be converted from one form to other. So the law of conservation of energy is the statement of first law of thermodynamics. So this law of conservation of energy, which is also defined as the first law of thermodynamics, can be stated in alternately in various ways. Secondly, it can be interpreted, or it can be described as the total energy of the universe. Total energy of the universe is constant. Universe means system plus surrounding. The total energy of the universe means energy of the system plus energy of the surroundings. So this is constant. And thirdly, we can express this in an alternate way, that it is impossible to construct a perpetual motion machine which could produce work continuously without consuming energy. So it is not possible to construct a machine which can produce work without consuming energy. So it is not possible. If it suppose it is true, then it must violate the first law of thermodynamics. The first law of thermodynamics is true and cannot be false. So that is why it is written like this. It is impossible to construct a perpetual motion machine which could produce work continuously without consuming energy. Perpetual means continuous, that is considered a continuous motion machine which could produce work continuously without consuming energy. Then lastly we can also describe the first law of thermodynamics in this way, that is whenever certain quantity of one form of energy disappears, an exactly equivalent quantity of some other form of energy must appear. That means total energy, as the total energy is constant, if the part of the energy of the system is converted into other form, the sum total of the energy remains constant. In a particular system, sum total of energy remains constant. So whenever certain quantity of one form of energy disappears, an equivalent quantity of some other form of energy must appear. So the same energy, the part of the energy which is disappears, it must convert itself into other form of energy, so that the total energy of the whole system must constant. So this is the qualitative description, my qualitative statement of first law of thermodynamics. We can express the first law of thermodynamics in a mathematical form. What is that? So let us consider a system. When we consider a system, let we uh, assume a thing that a system absorbs energy, q amount of energy, in form of heat, or release some energy in form of heat. So according to the sign convention, we may take heat gained by the system is taken as positive, and heat lost by this system is taken as negative. So this is the sign convention. Similarly, when suppose heat is absorbed, it must do some work. Suppose it uh, did some work on the system due to compression, and it must be uh, taken as positive. Similarly, work done by the system due to expansion, it is negative. It is the work of expansion is negative. So suppose consider the q amount energy is absorbed by system or gained by the system. What will happen when some amount of heat q is absorbed by the system or gained by the system, and the it did some work. Suppose the system did some work done is on this system. If the work done is on this system, this is W positive. So when Q amount of heat is absorbed and W amount of work is done, then there is a change in internal energy. Suppose first, before absorption of the heat by the system or work done by this system, that is E1, this is the initial internal energy. When some amount of Q absorbed by the system and it did some work W, then its final internal energy becomes E2. So, that is E2 is equal to E1. So E2 must coincide with E1 plus Q plus W. So you can write this E2 minus E1 is equal to Q plus W. What is E2 minus E1? This is the difference in internal energy. That is final internal energy and initial internal energy. That means the change. This is the change in internal energy. The change in internal energy is equal to Q plus W. So this is the mathematical form of first law of thermodynamics. So this is the mathematical form of first law of thermodynamics. So suppose if work is gained by the system and work is done by the system, means the work is negative. That in that case, delta E is equal to Q minus W. The work done by the system. The work done by the system is uh, P into delta V. Suppose we consider a frictionless piston uh, fitted with a cylinder, insulated. It is cylinder. Then some amount is let to be expanded. Suppose this is uh, the force applied on this cylinder, that means on the piston, that is F. So it can traverse a distance L, delta L. So what is the work done? Work done is equal to W is equal to F into delta L. If we divide F by A, this becomes P. And A into delta L means it is a volume figure. It is the volume dimension of the volume. A delta L means it is volume of the cylinder. Change in volume, delta V. So W is equal to P into delta V. So you can write delta is equal to Q minus P into delta V. So this is the final statement of the this is the cases in first law of thermodynamics. This is the cases. Suppose if the delta E is equal to 0, the change in internal energy 0, then here Q will be minus W. Q is minus W. If W is equal to 0, if W is equal to 0, delta E is equal to Q. The Q and W are the Q and W are the path function, but their summation Q plus W in first of thermodynamics, delta E is equal to Q plus W. So delta E is the path function, but the path function is the summation of some this state function. This is state function. Delta is the state function, depends upon the initial and final state of the system. So this is summation of two other functions, that is heat and work, which are path functions. So from the equations, if the delta V is equal to 0, then QV is equal to WE. So if the delta V change in volume is 0, then that is the work component of the mathematical statement of first law thermodynamics. This becomes Q is equal to delta E. Means Q means delta V is 0 means it is a constant volume. So the heat change in constant volume, that is equal to the change in internal energy. So the change in internal energy measure the measure of heat absorbed or heat released at constant volume and constant temperature condition. So today's this much, and we'll take up another subtopic, that is enthalpy, in our next class. Thank you.